So in this example, we are going to be applying Hamilton's method of apportionment. Obviously, a recurring problem with apportionment is caused by rounding, and we will find that for most of the problems that we will encounter. And the founding fathers knew that, and one of the founding fathers who wanted to address it was Alexander Hamilton. And his idea came in 4 steps. So this says, using the results from examples 1 and 2, use Hamilton's method of apportionment to allocate the 50 new computer tablets to the 5 schools within the metropolitan area. And here's the original table that we saw. Here are the 5 schools, school A, B, C, D, and E. Here's their corresponding faculty, 138, 103, 83, 47, and 79. And we wanted to allocate the 50 tablets. So we took the total using the standard divisor. We took the total, divided it by 50. We came up with a standard divisor of 9. Then we went ahead and we divided that 9 to each of the subgroups here. 138 divided by 9, and we came up with these quotas here, these standard quotas here, 15.333, 11.444, 9.222, 5.222, and 8.777. We then applied the quota rule, which says that you have to round to the nearest integer. So this rounded down to 15, this rounded down to 11, this rounded down to the nearest integer 9, this rounded down to the nearest integer 5, and then this rounded up to the nearest integer 9. However, the dilemma that occurred is that when we added all these up, it came out to be 49 tablet computers. So we had 1 tablet computer left over. So Hamilton had an idea of how to be able to distribute those leftovers. So he did it in 4 steps. His first step, I'll just write it here, step number 1 was to go ahead and find the standard divisor, which we did in example 1, and our standard divisor is 9. His second step was then to find the standard quota. I'm just going to write it as SQ, and of course we did that for each one. The standard quota here is in red, the standard quota for B here, 11.444, so we did that for each one. Of course, when we followed the quota rule and added them all up, we were left over with 1 extra tablet. So for step 3, Hamilton said to round down. No matter how large the fractional result is, round everything down. So this was rounded down to 15. This was rounded down to 11. For school C, this was rounded down to 9. D, this was rounded down to 5, and for the final school here, this was rounded up to 9. But Hamilton says to round down. So we're going to round this down to 8. However, now when we go ahead and we add all this up, that equals 48. So now we're left with 2 leftover tablet computers rather than 1. So then for his 4th step, step 4, he states to distribute any leftovers to the quotas with the largest fractional results. I'll just put down largest fractional results. So that means this 8.77, that has the largest fractional result, 0.777. So this 8 goes back up to 9. So the next fractional result is this one here, 0.444. So this will get a leftover one. So this goes from 11 to 12. So now when we add it up, 15 plus 12 plus 9 plus 5 plus 9, that equals 50 computers. So his method seemed to work.